Welcome to a quick overview of the Boltzmann constant, a fundamental constant in the realm of physics and thermodynamics. In just 2 minutes, let's explore what the Boltzmann constant is and why it holds such significance. The Boltzmann constant, denoted as K and often expressed in Joules per Kelvin, J/K, is a critical constant in the field of statistical mechanics and thermodynamics. Named after the Austrian physicist Ludwig Boltzmann, it relates the average kinetic energy of particles in a system to its temperature. The Boltzmann constant plays a central role in describing the behavior of atoms and molecules in gases, solids, and liquids. It's a bridge between the microscopic world of particles and the macroscopic world of temperature and energy. In thermodynamics, this constant connects temperature to the amount of thermal energy in a system. It allows us to understand how temperature affects the distribution of velocities and energies of particles, helping to explain phenomena like heat conduction and diffusion. Scientists and engineers use the Boltzmann constant extensively in fields such as materials science, chemistry, and astrophysics to calculate energy distributions, predict behavior at different temperatures, and design efficient systems. Understanding the Boltzmann constant is crucial for those involved in research, especially in the fields of thermodynamics, statistical mechanics, and quantum mechanics. It provides a fundamental link between the microscopic world of particles and the macroscopic world of thermodynamics. The value of the Boltzmann constant, approximately 1.38 times 10 to the power of negative 23 J/K, represents a fundamental constant that underpins our understanding of the physical world, making it a cornerstone of modern physics. Stay informed and physics savvy. Recognizing the concept and importance of the Boltzmann constant is key to grasping the behavior of matter and energy at both the atomic and macroscopic levels, enabling advances in science and technology.